Good morning. We're ready for section 16.4. Now, from here on out, we're going to be like taking off like a rocket ship, okay? So like we are just going to go and boom out of here so that we can finish this section out. Okay, so look in your book on 324 on section 16.4, scientific notation. Now, before we close out our exploration of exponents and square roots, we're going to take a look at an entirely different application of exponents, and one you might not expect. Exponents help us concisely record numbers that would otherwise require an unwieldy number of digits. For example, the mass of the Earth has been calculated at approximately, I don't even know how to say that number. Can you imagine trying to write it often, let alone multiplying or dividing it with other lengthy numbers? We also encounter lengthy microscopic numbers such as the rest mass of an electron, approximately blah, 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 blah. Again, imagine trying to keep track of all of those zeros. Now, there are numbers like that. Thankfully, there's a method for expressing numbers with lots of digits more concisely. This method is called scientific notation. Now, that sounds scientific, doesn't it? Well, it sort of is, but it's really stinking easy. We're just going to pay attention to the decimal, really. Okay, take a look at it. Now, expanding the notation. Before we get started, we need to expand on exponents just a little. So far, we've had exponents like 2, 3, 5, etc. But exponents can be other numbers too. Let's take a look at what happens when we use 1 and 0 as exponents. Now, a number with a 1 as an exponent equals itself. Okay, 10 to the first, or excuse me, 2 to the first equals 2. 10 to the first equals 10. 5 to the first equals 5. It equals itself. Now, on the other hand, a number with a 0 as an exponent equals 1. 2 to the 0 is 1. 10 to the 0 is 1. 5 to the 0 is 1. Okay, keep that in mind. Okay, now this gray box tells us why that is. I'm not going to read that to you. You can read that for yourself. Now, let's move on to the understanding scientific notation. At the bottom of 325, this little diagram thingy-majigger is very important. Now, to understand scientific notation, we have to review our place value. Okay, notice how every place in our place value system can be represented by 10 or 10 raised to a power. Okay, so look at the ones. Okay, ones is 1 or 10 to the 0. Look at the tens. That is 10 to the first. Look at the hundreds, 10 to the second. The thousands, 10 to the third. 10,000s, 10 to the fourth. You see the pattern there? And it continues to go up. Okay, so 10 to the 0 is in the ones place because it means 1. Okay, 10 to the first means 10. It's in the 10 section. 10 squared, or 10 to the second, is 10 times 10, which is 100. 10 to the third is 10 times 10 times 10, which is thousands. Or 10 to the fourth, see the pattern? Okay, that's a very important thing to know. Look at the top of 326. Now, we could represent the decimal places using exponents too, but we're going to save that part for book 2. So knowing what we know then, let's take a look at how, rather than using place value, we could represent a number as a multiplication of a power of 10. We'll take 4,000 as a simple example. When we write 4,000, the place or location of the 4 tells us that it represents thousands. However, if we didn't want to use place value, we could represent 4,000 as multiplication. 4 times 10 times 10 times 10. We could further simplify this by using an exponent, 4 times 10 to the third. Likewise, 4,900 could be written as 4.9 times 10 times 10 times 10, which would be expressed with the exponent 4.9 times 10 to the third. Now, stop and do the math. 4.9 times 10 is 49, because remember, when you multiply by 10, you just move the decimal one place to the right. Okay, 49 times 10 gives you 490. 490 times 10 gives you 4,900. So 4.9 times 10 times 10 times 10 equals 4.9 times 10 to the third, which equals 4,900. So 4.9 times 10 to the third is representing the same quantity as 4,900. Notice how all that puzzles together. So both 4 times 10 to the third and 4.9 times 10 to the third are written in what we call scientific notation. Scientific notation is a way to express a number with only one digit to the left of the decimal. Using it, even numbers with many digits can be expressed with ease. For example, 5 blah blah and all those zeros. I don't even know what place value that is. In scientific notation is 5.9722 times 10 to the 24th. Notice that in scientific notation, we don't have to wonder how many zeros there really are or worry we'll forget one. We can easily see the number's place by looking at what power 10 is raised to. So how exactly do we work with scientific notation? I'm glad you asked. Let's take a look. Okay, so to put a number into scientific notation, these are the two things you do. Number one, you move the decimal point so there's only one digit to the left. Then you multiply by 10 raised to whatever power the exponent is needed to put the digits in the appropriate places. Basically, you just count how many times you go over to put the decimal where you need it to go. It sounds easy enough. So basically, when you look at the top of 327, when you are putting a number into scientific notation, you are actually dividing by a power of 10. Remember, when you divide by 10, you move the decimal to the left. Okay? So moving the decimal place to the left 2 places is the same as dividing by 10 squared. So if you have 490, this is at the top of your page, and you want to put this in scientific notation, well, you know the decimal's here. It's just a given. Remember, the first thing you do is you have to move the decimal until you have one digit to the left. How many times did we move it? Okay, we moved it twice. So that's the same as doing this. You write all your digits that are not zeros. We moved it twice. That's all you do. Okay? So you move your decimal to the left as many times as you have to until you only have one digit to the left. And then you write that out using all the digits that are not zeros times 10 to the however many times you had to go over. Look at the example on 327 in that gray box. Express 59722 blah 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 in scientific notation. All right, so basically all you do, well, I really need to write this number, but I'm going to do it a little bit differently. I just want to show you how they did it. I'm afraid that's going to be too big. So 59722. Now how many sets? 1, 2, 3, 4, 5, 6. So that's going to be 18 zeros. Am I right? 1, 2, 3, 4, 5, 6. Is that right? 6 zeros? Did I do it right? 6 sets, I mean. 1, 2, 3, 4, 5, 6. Yeah. Okay. So there's my number. Now what they did to write this in scientific notation, all you do is you know the decimal's here. We know it's understood to be right there. Well, we have to move the decimal from here to right here, because we have to have one digit to the left. So let's count how many times we have to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So our decimal is going to go there. It's going to be 24 times. So then what we have to do is we have to write all of our numbers that are digits, not zeros. So it's going to be 5, this is in scientific notation, 5.9722, because you have to write all the numbers that are not zeros, times, how many times did we divide by 10? 24. Ta-da! Scientific notation. Is that not easy? Now, the next section says converting from scientific notation. So say it gives you scientific notation and you have to undo it. Okay, well, you undo it. That's all you do. If it gives you, look at on 327 where it says multiplying by a power of 10, because when you undo it, that's what you're doing. You're multiplying by a power of 10. So if you have 4.9, they give you that example, times 10 to the second power, okay? Basically, this tells us how many times we need to move the decimal. We need to move it twice. So it's going to go 1, 2. That means we need to add another 0. Okay? Because remember, it was right here. This is where it was at. So to undo it, we multiply, which means we go to the right, however many exponent numbers you have. And this one's 2. So 1, 2. So your answer is 490. That's all you do. Okay, now look at the very bottom of 327. There's another example, converting 5.9722 times 10 to the 24th back to decimal notation. You're just undoing this number. So basically you say, okay, well, the thing's here and we have to go to the right 24 times. Okay, so that would be 1, 2, 3, 4, and then you're gonna have to put 20 zeros. Okay, and that's what this is, 20 zeros. And then that would be it. You're just going back the other direction. Okay? So when you put it into scientific notation, you're dividing by 10, so you're moving the decimal to the left, however many places, that's your exponent number. When you're undoing that, you go the other direction. Does that make sense? Okay, so your assignment then is going to be do page 16.4. Should be pretty easy. But I'm not going to grade it since it is the beginning of something that we've never done before. So let me know if you need any help on this. It should be really, really, really easy. But I'll be happy to go over it if I need to. Okay, that will be all for today.